Imagine a world where science creates your food, offering the same taste, texture, and nutrition as traditional options, but with added benefits like sustainability and convenience. From fortified cereals to lab-grown meat, engineered food solutions aim to provide what nature does, but with modern innovation. But can these breakthroughs truly replicate the rich, natural complexity found in whole foods? The debate over replacing nature's design with human engineering goes beyond innovation. It's about understanding what our bodies need to thrive. Whole foods like fruits, vegetables, meats, and fish have a unique advantage: nutritional synergy. They provide a balanced mix of macronutrients, proteins, fats, and carbohydrates, and micronutrients like vitamins and minerals. But it's not just about having the right nutrients, it's about how those nutrients are delivered. Whole foods offer bioavailability, meaning their nutrients are in forms the body can easily absorb and use. Even more importantly, the nutrients in whole foods work together in harmony. For example, the iron in red meat comes with cofactors that naturally aid absorption, unlike isolated supplements. This combination makes whole foods unmatched when it comes to supporting energy, muscle function, and brain health. Engineered nutrition, from fortified foods to lab-grown alternatives, offers undeniable benefits. By enhancing specific nutrients, scientists can create targeted solutions to combat deficiencies, such as vitamin D in fortified milk or iron in cereals. These advances have made nutrition more accessible, especially for populations lacking varied diets. But engineered foods face significant challenges. For one, nutrient absorption is not guaranteed. While a nutrient may be present, it doesn't mean the body can absorb and use it effectively. For instance, fortified iron often requires vitamin C for proper absorption, unlike heme iron in natural meat. Overfortification can also lead to health risks. High levels of isolated nutrients like synthetic vitamin A or calcium can cause toxicity and long-term health issues. And perhaps the biggest challenge is replicating the cofactors and natural interactions that make whole foods so effective, something that engineered foods often lack. The supplement industry offers a cautionary tale about the limits of engineered nutrition. Many supplements provide nutrients in forms that are less effective than those found in whole foods. Take beta-carotene supplements. Initially promoted for their ability to boost vitamin A levels, they were later linked to an increased cancer risk in smokers when taken in isolation. Another example is calcium supplements, which are less effective than calcium from dairy or leafy greens, where they naturally coexist with magnesium and vitamin K to aid absorption. These examples show that isolated nutrients often don't behave the same way in the body as those in whole foods, highlighting the complexity of nutrition science. Lab-grown meat is one of the most exciting engineered food innovations, promising the taste and texture of traditional meat without the ethical and environmental concerns of livestock farming. However, matching the nutritional profile of real meat is a far more complex challenge. Lab-grown meat can replicate muscle tissue, which provides protein, but it often lacks other key nutrients. For instance, real meat contains collagen, which supports joint and skin health, something lab-grown meat doesn't yet offer. Iron and B vitamins are another hurdle. While these can be added artificially, their bioavailability might not match that of their naturally occurring counterparts. Heme iron in natural meat is easily absorbed by the body, while fortified iron might require additional cofactors for effectiveness. While lab-grown meat can mimic some of the protein content of real meat, achieving the same nutritional quality remains a significant challenge. Nutrient synergy is a critical reason why whole foods outperform their engineered counterparts. In whole foods, vitamins and minerals work together to boost absorption and effectiveness. For instance, vitamin D helps the body absorb calcium, and vitamin C enhances the absorption of non-heme iron. This natural balancing act ensures that the body receives nutrients in the right combinations and quantities, reducing the risk of toxicity or imbalances. Additionally, whole foods contain compounds that science is only beginning to understand, many of which play roles in how nutrients are absorbed and used. Replicating this intricate network of interactions in engineered foods is a monumental task. Fortification and lab-grown alternatives also carry risks that aren't always apparent. Iron overload, for example, is a serious concern when excessive iron intake leads to toxicity, especially in individuals who don't need supplementation. Similarly, high doses of synthetic vitamins like vitamin A can cause harm, Unlike whole foods, which naturally balance nutrient intake, engineered foods can create an imbalance if not carefully managed. These risks highlight the challenges of creating foods that mimic the safety and effectiveness of whole foods. Engineered nutrition is undeniably remarkable, addressing global challenges like food security and nutrient deficiencies. But as advanced as these solutions are, they often lack the natural synergy and bioavailability of whole foods. Whole foods provide a complexity that goes beyond the sum of their parts. The natural balance of nutrients, their interactions, and their delivery mechanisms make them irreplaceable in many ways. While engineered foods, like lab-grown meat, can play a valuable role in a balanced diet, they are not yet a complete substitute for the nutrition found in nature. So, can engineered nutrition truly replace whole foods? Not entirely. While innovations like lab-grown meat and fortified foods are important steps forward, they cannot yet replicate the full spectrum of benefits that whole foods provide. As science advances, the goal should not be to replace nature, but to understand and enhance it. By blending innovation with an appreciation for what whole foods offer, we can create a future where nutrition meets both the needs of humanity and the health of the planet. Thank you for watching. If this exploration sparked your curiosity, don't forget to like, share, and subscribe. Join the conversation in the comments below, and let's keep uncovering how science and nature can work together to shape the future of food.